If you've connected a microphone to your radio and you're not happy with how the audio sounds, the most likely culprit is the EQ or equalisation. This video shows you what you need and how to go about setting it up. EQ is all about adjusting the amount of energy at different frequencies that are present in your voice. And there are lots of ways of doing this, from physical rack equipment to plugins within software to within the radio itself. And this video will use a thing called a parametric EQ, and that's because it's the most flexible and the simplest to understand, as each EQ doesn't affect the next. I'll go into this in slightly more detail. I won't be using a graphic equalizer in this video. I will quickly show you why I don't like graphic equalizers. Right, I'm using a thing called Plugin Doctor here, and it's a great tool to analyze what's going on in plugins. So I'm going to do all of the work here on the computer using plugins because it's much easier showing you on plugins than it is on physical hardware, but it's exactly the same. In fact, a lot of plugins mimic physical hardware. So I'm just going to start moving some of these graphic equalizer peaks around. So you can see there, so the pink line is this graphic equalizer. The red line is the parametric equalizer. So I'm just going to start raising a few EQs up here on the graphic equalizer. So hopefully you can see already that this shape here it's very difficult to predict. You know, as I start lifting up different bands, they all interact. And in fact, I've just drawn a little shape there. I've got some wiggles in there. Now with this one, I can actually draw an EQ as well. If I can remember how to do so. There we are. Let me draw a curve. And I need some more gain here. There we are. So I've tried to draw quite a straight curve there, and I've got all these wiggles. It's wiggling up and down. Nothing you can do about that with a graphic equalizer. And so I tend to stay away from them for that reason. Maybe it's not going to affect the audio quality that much, but there can be an issue. But when somebody's voice has always got a bit of what I call vibrato on it, there's going to be a bit of frequency modulation on the voice. And as that frequency changes, it's going to go up and down these little bumps and actually cause a bit of distortion because it's going to modulate the amplitude of the frequencies. I won't go into that much in this video. I'll talk about distortion and intermodulation distortion in the dynamics video, but it's not a good thing to have a tight filter like that, really, that's going up and down. A parametric EQ, on the other hand, is much more controllable and definable. So in fact, I don't really need Plugin Doctor to see this. You can see it very well on the display within this Neutron 3 equalizer. And plugins with these kind of displays are absolutely great. They let you see exactly what you're doing. And a parametric EQ has a frequency, a gain, so you can see there, gain in dBs, plus or minus, and a Q. And the Q is the sharpness of the filter. So the higher the Q, the tighter that filter becomes. And some filters, rather than a Q, they have the bandwidth in octaves. And the bandwidth in octaves is defined by this equation. And there are lots of websites which let you convert between bandwidth and Q. So it's the equivalent. This Neutron has a few different types of filter, just to confuse things. So we've got Bell and proportional Q. This is to do with the slopes. Now, not many filters actually have this adjustment, I don't think, but exactly what the difference will be, I don't know. Bell, you can see there from the diagram, it's got a slightly smoother response at the top that may result in slightly less distortion or artifacts if there's a bit of vibrato in the voice. But other than that, I'm not going to go into exactly what difference that is going to make to the overall sound. What we're going to look at in this video is actually creating a sound curve, a profile that affects the tonality of the audio. There are also other types of filter, not just Ballard proportional Q. We've got low shelf. Let me just reset this actually. So let's do this one. One is a low shelf by default. So that's pulling, you can see what it's doing. It's pulling all of those frequencies down there. I can adjust the Q of that and you know, expand that. There is a Bexendal, you know, oh, there you go. You can just see the response. I'm not going to go into all these different filters, but you can see exactly what gain it's giving the frequencies there as you adjust this. A low pass filter is something that passes low frequencies only, and you can see there I've got a low pass filter at 1000 Hertz. There's 1000 Hertz or 1 kilohertz, and that point there is the -3 dB point, it's called. So the cutoff of a filter is always when it's got to half power, -3 dBs. As I change the Q, the steepness of that filter will move there. And likewise, there's a high pass filter which passes everything above the cutoff frequency. The slope there, 24 dBs per octave, that's the slope of this. So 24 dBs per octave means it's going to drop 24 dBs every time the frequency doubles. 1 octave is 1 doubling in frequency. Okay, so I've got a simple test setup done here. I've got my my sphere microphone, and the audio's going via that dotted line there into an equalizer, then into some dynamics, and then into OBS, which I'm using to record. So this is a virtual interface which OBS is picking up. I am running some dynamics because I want my audio to be a consistent level, and I'll just bypass that just to show you what that's doing. So it's kind of making it a bit louder. Notice it's colouring the audio as well. It's making it sound much deeper. So interesting effect. I'll go into that a bit more when I talk about compressors. And anyway, we're here to look at EQs at the moment, so that's helping control my audio. And here's an equalizer, not doing anything at the moment. Okay. This is my audio spectrum, just on the left here. So that's 100 Hertz, 1000 Hertz, 10,000 Hertz. So you can see I've got lots and lots down there in the low end. And this diagram here, the octave spectrum, shows you how much energy I've got at all those different frequencies. So these are the frequencies labeled in each one. This bit of software, by the way, is called Fritcher, and it's completely free. Really, really useful bit of gear. And you can actually do little recordings as well if you enable that option. Listen to your own audio, which is useful. Right, so let me bring that back up there. So it sounds a bit muddy, I would call it, already, and that's very common thing you'll get from microphones. And if I move a bit further away, actually there's not much proximity effect on this microphone, but with a lot of mics, as you move towards them, they get lower and lower. So it doesn't sound great audio, does it? I'd say that sounds very muddy and boomy, not particularly great. But now, when you transmit on a radio, this is really wide. You know, you can see that's frequencies there going out to 10 kilohertz at that point. There's some going out even further towards 20. So on a radio, you limit the bandwidth, and this filter is great. It has a brick wall filter. I'll start that wide. So this is cutting off all frequencies above this one. So that's 13, and as I wind it back, you can hear the high end going further and further. And this 3 kilohertz or 2.9 is the usual maximum frequency that you transmit. Now listen to how boomy that sounds. So it's kind of amplified all that horrible low end that was there already, and it doesn't sound very clear at all. This doesn't make very good communications audio. So you have to pull stuff out at the low end, and one of the magic frequencies is so let me pop that one back. Let's try this one. There we are. If I carry on down here and keep going at 160 hertz, can you see that? And it's definitely getting a lot better there. If I just widen that up maybe slightly, see how much I can get out. -10. I could probably do with taking some more out actually. Still sounding a bit boomy, isn't it? So let me grab another one. Q of about 0.7, which is kind of 1 octave, and I'm going to put out even more at 160, and that kind of boominess is starting to disappear, getting better and better. See what I've got this one set to. Make that one 0.7 again as well. Okay, so it's starting to sound a bit better now, so I'm starting to flatten out this big hump that you can see there in the low end. I'm starting to flatten it out, and let me grab hold of another filter here, and I'm going to pull even more out here, so about 300 odd. Go to 0.7 on the Q again, and let's pull a load out at that point there. 1, 2, 3, 4, 5, 6, 7, 8, and I could go to this one here, 0.7, pull a load out there, even about sort of 500, and so on. And I've kind of got rid of most of the muddy hump, I'll call it. There's loads now down the bottom. Don't know if you can hear that, but it's really grumbling down the bottom. Now that's what a lot of people on the radio really like. So they like a nice little bit of rumble down the bottom, and this is how it's done. Normally 3 kilohertz bandwidth, you don't really want that. So I'm if I make that a high pass filter, just do a flat high pass filter, 12 dB slope, and I can just sort of cut the bottom off, and there we are. That's sounding much better communications grade audio, if you like. That is the basics of EQing your audio. If you want some higher quality, go to 4 kilohertz or 4.2, go out to 4.2K, and I'll turn off this low pass filter, and see there's still sounds a bit boomy, doesn't it? In fact, what I'm going to do is take a bit more out, and it turns out that normally 80 hertz is a good number as well. So 80 hertz, 0.7 again, and I'm going to take out a load of the boominess. So there we go, 10 dBs at about 80, and a lot of that boominess is now gone. Going to do being a bit wider. You can play around with this a lot. You know, it's very difficult. Depends on your microphone and your own voice a bit as well. But that's a good starting profile. So, show the sidebar. Oh, where's that gone? There we are. Let's get These are ozone plugins, by the way. I've got lots and lots of plugins, but these are very good and very graphical to demonstrate what's going on. I don't use them normally when I'm on the radio anymore. I've got a different system. So MN Neutron 3 equalizer. Let's try this one. We could imagine that this filter has actually had a lift up at this point. So if I just reset this again, actually I'm going to just save this one. Let's go and I'm going to put 0 first EQ, because then it appears at the top of the list. Magic. I can go and find it again. So reset this, and I'm now going to grab this again, and this time I'm going to create a band shelf. There we go. So a band shelf centered around sort of 150, and then widen that up. Okay, so I'll pull a bit more out. Now that is a reasonable way of doing it, but doesn't sound quite as nice, does it? Let me just widen that out, actually. Widen that a bit more. Maybe that's better. So a band shelf is an option. It doesn't give you as much control of the slope in that region, which can be quite important. So I don't tend to use band shelves. I haven't ever got as good a result as when I use individual bell filters. So I'm going to get rid of that one. The other thing you could do is lift the top. So I could make this one so a high shelf, an analog high shelf, and just kind of boost everything up here, and you know, that's a valid way of doing it. Don't know if you can hear, but it has got a different kind of tint to it. It's not sounding, I don't know, not too bad, but actually that's better if I put it about there. And of course we're missing the low end, so if I grab a low shelf there, I'm kind of carving out the same shape, but it's very difficult doing it that way. It's easier to go back to this one. It's easier to cut it out and get the sound that you actually want. I don't really know why, to be honest. I'm sure you could achieve the same thing by boosting as cutting, but it seems a lot more difficult. You can do small cuts and not hear them. Okay, so if I kind of do a small cut there, well, you can hear it obviously, but if I, you know, so I'm removing a very small section there. If I boost, you have a listen to this. Listen to that awful ringing. So I've gone up 10 dBs gain there. That's sounding very ringy. If I go down by 10 dBs, it hasn't changed the balance particularly, has it? That's because this notch of frequencies is kind of hidden by others of a similar level within it, and you don't really hear the difference. If I move it above, it really stands out and it sounds horrible. So generally what you do is you cut small bandwidths to improve your EQ, and if you want to boost, make it a wide boost, make it a wide lift in a particular area, and that way you won't get any horrible sounds in the audio. Those horrible sounds, by the way, are they can be useful. So Once you've got the balance of your audio right, you can go looking for problem frequencies, which are normally resonant frequencies. And resonance is caused by sound waves bouncing off of nearby objects, coming back to the microphone and adding together and causing a peak. Or it might be the mic itself, if it's a cheap microphone with a vibrating metal foil in there or something, or resonance in the mic diaphragm. I've never come across that though, to be honest. You get good mics for very good money now, so it's not really a problem. It's going to take a little bit more out at 80 actually here. I'm listening to myself while I'm doing this, and sounds a little bit boomy still down the bottom. There we go. So I'm now going to go looking for resonances. So I'm going to do a narrow Q, so 7 or 8. You can hear that starting to come in there. I'm going to move the frequency around and actually listen for problems. And if I kind of sweep this along, it sounds like you've got a problem everywhere sometimes. But what you're looking for is like a particular standout nasty noise. Nasty. Oh yeah, there we are. So there's kind of one there. It's not very nice. Let me keep going down in frequency. Oh, there's a little one there. Okay, so it's kind of indicating we might not have quite enough out in that region, possibly. But anyway, once you've found one of these problem frequencies, keep scanning it around. I've normally got one about up here. Not sounding too bad today, actually. Right, you can hear a horrible sort of resonance. When you get one, pull it down, few dBs, 4 or 5 dBs, widen it out, and then you notch out the problem frequency. So let me add another one here. Let's I'm making them narrow so I can hear the noise more easily, but it's easier to center on the problem frequency. So I'm just going to move this around again here. Definitely something a bit funky going on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, sorry, that's enough of me ranting. And okay, so I think there's something. I haven't got any really problem ones actually, but let me get rid of this. 758 hertz. Take a few dBs out, widen it up. Okay, so you can carry on doing that, and that really polishes the final audio. You can get a really nice smooth profile. I'm just going to go back and look at the bandwidth again. So you can hear, if I increase the bandwidth, the clarity of the audio really comes up. Okay, so a little bit of extra bandwidth can make a very big difference. That's why if you go on the radio, if you're into amateur radio, you may hear a lot of people using 4 kilohertz because it just adds so much more into the audio. Listen to that. And remember, the radio's brick wall as well. If I go back to a brick wall filter, there we are. So there's our 2.9 kilohertz, and I'm going to move this one out there to 4 odd kilohertz. And can you hear the ringing though? Hear that really tight ringing sound? This may be an issue on air. I think this depends on the type of radio being used, but software-defined radios create really tight filters like this, and that can kind of make it sound brittle in the top end. Analog radios actually have a much flatter response like that, and but as a result, see these outer band transmissions, if you like, coming out of here. Sounds a bit less ringy in the middle, but there's lots of energy coming outside there. So I'm going to go back to the brick wall filter. But if there is ringing, if you can hear this on your radio, just add another filter. Let me add a flat low pass, and I'm just going to just cut that off slightly earlier. Now that's got rid of the ringy noise without sacrificing getting lots of outer band transmissions. I just want to talk briefly about the pink noise line and adjusting your audio to match this line. So I've gone over onto my Sun SDR software, Expert SDR2, and it's got a very convenient monitor function inside which shows the audio level and the pink line. So you can see there is the pink noise line. The pink noise line is 1 over the frequency. It's a slope of 1 over the frequency, and that represents the amount of energy that's at each frequency point. So if this is an oversimplification, which I'll come on to in a minute, but generally if the audio level's matching this pink line, it should be heard at the same volume all the way up the frequency range, because every time the frequency doubles, the amount of energy doubles at that frequency, and your ear hears that amount of energy. So this is kind of keeping all frequencies level. Now that isn't quite right, because there's I think they're called the Fletcher-Munson curves, and there's a study being done on human hearing, and it's not flat over the frequency range. It doesn't just follow the energy. But this is kind of the basic the basic shape, I suppose, that you're looking for. Now you can see mine isn't actually quite on the pink noise line. I might have a bit too much energy here, about the 500 hertz region. I know some people say that I have. That's kind of how I end up EQing it most of the time. I don't know why. So it's just my ear really, and how I hear the sound. But anyway, this can be a good indication. If you've got a spike, a big peak somewhere above the pink noise line, then it's worth just bringing it back down, or just listening for it. You'll probably hear it, and then you can add a filter to remove it as well. I hope that's given you a good introduction to EQing your audio for radio use. And stay tuned for other videos on compression and other aspects of the audio chain, which are very important for great sounding audio. Thanks very much for watching, and please like and subscribe if you enjoyed the video.